Hey, welcome back. So today we're going to be talking about how to solve very basic physics problems with forces. I'm assuming you know almost nothing about forces, and you need to learn something about how to solve problems, very foundational problems with them. So this is appropriate for physical science students or for very introductory physics students. And what I want to present today is a very powerful strategy that I've used in physics classes and AP physics classes for years, and it helps students to be able to just solve these problems in a very systematic way. So we are going to talk about that system, but first I want to talk about some basics. So real basically, we can say that a force is just a push or a pull, and I've shown four forces here. So the four forces that we're going to be dealing with today, let's imagine a book on a desk. And our four forces we're going to be dealing with are an applied force. That would be as if you grabbed this book and pulled it to the right or pushed it to the right. That would be an applied force or the force applied. Either way you want to say that is fine. And the dot is going to represent the object. That's the book. So it doesn't matter if you're a great artist or not a great artist. You can represent the object as the dot. This is called a free body diagram. It represents the forces that are on that object, not from that object. So we have another force here. This is going to be our force due to gravity. This Fk is going to be our frictional force. Specifically, it's kinetic friction force because we're going to assume the book is moving. It's being pushed or pulled to the right, and so it's got a frictional force going in the backwards direction. The last one's a little trickier. It's called the normal force. If you think about it, the book is pushing down on the desk is pushing back up on it with the same amount of force. That is Newton's third law. And that reaction force that's perpendicular to the surface is called the normal force. In this case, when we say normal, we're not talking about like regular, we're talking about perpendicular to or at a right angle to. That's actually what we mean by this sense of the word normal. All right, I'm going to throw up some definitions here in case you want to pause and read the background for what I've written for these ideas, but we're going to move forward and see what the strategy is going to be able to do problems like that. So the first strategy is you're going to draw the free body diagram of the object itself for the problem itself, and these are the forces again on the object, not from the object, but on affecting the object, on the object itself. The first line for the sum of the forces strategy is you're going to sum up the forces that are completely in that axis, either the x-axis or the y-axis. Then you're going to write Newton's second law for that axis. So I'm going to show you what this looks like. Newton's second law is the sum of the forces is equal to mass times acceleration, or net force you could say is equal to mass times acceleration. So I'm going to show you this, and then you're going to set them equal to each other and see what happens. Let me show you what this looks like. This is the net force. So don't let this symbol right here freak you out. It just means the summation of, or the sum of the forces. Here, this is in the x-axis. This, by the way, is called a subscript. It's just there as a label to help us to know what we're talking about. So this literally means the sum of the forces in the x are equal to, and we just literally sum them up. So this is the force applied, and that's going to be treated as a positive value. Forces are vectors. That means positive and negative do really matter with them. And so we have to treat this as a negative value because that Fk value over here, that kinetic friction force, is operating in the negative direction, the opposite direction of positive. The second line for the sum of the forces strategy, like I said, was going to be to write Newton's second law. So the sum of the forces in the x is equal to mass times acceleration. So, notice we've got this thing is equal to something, and then we've got that same thing is equal to something else. So what we're going to do is set these two things equal to each other, and if we do that, then we get this combination or composite equation that we can do some useful things with. Alright, and so let's see how this works in the context of a problem. So here's a problem, and it says some sled dogs pull a sled that has 55.0 kilograms of mass in the forward direction with 43.2 newtons of force. The force due to kinetic friction is 15 newtons. What is the acceleration of the sled? So in the view of the picture, the forward direction is going to be actually considered to be positive, but in our free body diagram, we'll make to the right positive over here. And so one of the first things we want to do actually, and before we even start with the sum of the forces strategies, we want to start writing down the things that we know from the problem itself. So physics problems are like word problems a lot of times. You're going to take them and write down things that you know from the word problem essentially in terms of variables that we know. So for instance, Fa is equal to 43.2 newtons, and the mass is here, and the Fk is here. A lot of students will skip this part, but it will make life easier if you do this. It seems like it's more work, but it's actually just clarifying the problem. Next, let's use the strategy. So we're going to write the sum of the forces and then literally just sum up the forces in the x-axis. So we have Fa plus negative Fk. Second line is Newton's second law, which is what we see over here. Then we set them equal to each other. Now the next line, I kind of skipped one step, but I just want to explain what I'm going to do here. You're going to divide both sides by m. If you divide both sides by m, notice that'll cancel out this m over here, and you'll be left with acceleration of the x by itself, which is what you want to do. And so I do want to point out that that is what we're trying to do, because we're trying to solve for the acceleration of the sled. One more thing, I'm just going to drag the a over here, and so we're going to have Fa minus Fk over m. So that's what we have. Fa minus Fk over m is equal to the acceleration of the x. Now we are ready to plug in our numbers, not before, but now we are. And so we go ahead and plug in our numbers, and we end up with our answer in terms of meters per second squared. So hopefully this has been helpful. If you have any questions or comments down below, please let me know. And I hope you all have a great day. Take care.